Let's imagine you're looking at a line, you've got to write the equation of a line, but this time the line doesn't fall readily through known intercepts. In fact, let's draw one where it travels not through easily defined intercepts. So let's go ahead and do that now. So let's imagine, but you can see points that it actually goes through. So for example, you can definitely see it goes through this point here. And let's say you can also definitely see that it goes through, let's say, this point, more like that, this point over here. Yeah. So it's going through those points there. So let's see what that would look like. So I'll try and draw this as best I can. But you're looking for those points where you can definitely see that it actually goes through a well-defined point. So there it is there. So you can see the points it goes through, and this time you can see it's going through, what's that, 4 along, 3 up, so it goes through 4, comma 3, goes through there. And it definitely also goes through, that's going to be -4, -2. -4, comma, space, -2. Okay, good. And so you can see that it actually does travel through those points, but there's no readily useful point on the x or y axis. I mean, it looks like it's about half up. The y-intercept looks about a half. Here it looks it's about 3/4 or 2/3, -3/4, -2/3, but we can't be sure. So now we're going to have to work a little bit of magic and work out what things would be, because we don't have a y-intercept, we don't have an x-intercept so well defined. But what we can do, of course, is we can find our gradient. And the gradient's nice and simple to find, because all we do is we can see how far along we've had to travel here. We always go along. We always start at the leftmost point. We go along. We got 1, 2, 3, 4, 5, 6, 7, 8. This is 8 along, yeah? And here we've gone 1, 2, 3, 4, 5 up. Okay, fantastic. So this is 5 up. So our gradient is rise over run. So let's write here, m is equal to rise over run equals, and what's the rise? Well, the rise is +5. It's going up 5. It's also going along in the positive direction. It's going along 8. So the gradient is 5/8. So now we just have to work out what the y-intercept is. So lots of ways of doing this, and probably quite a useful way. We could use y equals mx plus c. So in fact, why don't we just do that? We could take any x and y point we've got. So let's go ahead. So we know that y equals mx plus c. We know what m is, so y, and we know what y is. I'm going to use y as 3. So y is 3 is equal to, this is going to be 5/8 times x. What's x? X is 4 times, I've got a 5 in the middle there, 4, okay, 4 plus c. So let's go ahead and work this out. Well, I've got 4 over 8. I'm just going to divide that. It's just going to become basically a 2. So I'm going to cross those out and replace that with a 2. So 3 is equal to 5 on 2 plus c. I'm going to subtract 5 on 2 from both sides. That's not very good, is it? Okay, so c is equal to, and that should be an equals there. C therefore is equal to, because this is now all disappeared on this side, I've got 3 minus 5 over 2. So just to be sure what that is, so what do I got here? 3 minus 5 over 2. So 3 minus 5 over 2 is 1/2. That works well. So C is 1/2. And that was a good guess, by the way, when we said that looks about 1/2. Means we've at least drawn it reasonably accurately. So now we can label that point. We can say that's going to be 0 along, comma 1/2. So now we can say y equals mx plus c. Therefore, y is equal to, and we go 5/8 x plus 1/2. And there is our equation.